We are looking at how to solve quadratic equations using the square root property. Now, the interesting thing about this example is that our solutions will actually be complex numbers. Let's solve the equation m squared plus 40 equals 0. To use the square root property, we first want to isolate the variable m squared. This means we want to move the 40 from the left side to the right side of the equation. To do this, we use reverse operations. We're going to subtract 40 from the left side and subtract 40 from the right side. And that will give us m squared equals negative 40. Now, let's take a moment and look at this equation more closely. Notice there is no real number that we could put in place of m, so that when we squared it, we got back a negative number. That's impossible in the real world. This is where the complex solutions come into play. We need imaginary numbers to make this equation true. So let's solve for m. How are we going to solve for m? We're going to use the square root property, which tells us to isolate the variable m when it's being raised to the second power. We take the square root on both sides. So we'll square root the left side and we'll square root the right side. But recall, the square root principle also tells us that we will have two solutions because both the positive square root and negative square root would satisfy this equation. On the left side, we have the square root of m squared, which is just m. And on the right side, we have the two solutions, positive and negative square root of negative 40. To finish, we simply need to simplify the right side. Now again, we have a square root of a negative number, which we know is not real. This means we're going to have imaginary solutions. So let's just do a quick little recall here. Remember that we've defined the square root of negative 1 to be the imaginary number I. We'll use this idea when we go to simplify the square root of negative 40. We have m equals plus or minus the square root, and now I'm going to break up negative 40 as the factors of negative 1 times 40. So now that you can see right here the square root of negative 1, this is going to give us our I, and so we have that m equals plus or minus I times the square root of 40. Hopefully you see we're not quite done simplifying yet, because 40 can be broken down. 40 is actually 4 times 10. And you could break it down farther if you wanted to into prime factors of 2, 2, 2, and 5. But I usually like to stop here because I know that the square root of 4 is 2 and that the square root of 10 cannot be simplified farther. So at this point, I will simply write my answers to be m equals plus or minus I. The square root of 4 we said was 2. And then times the square root of 10 is just the square root of 10. Let's clean up these answers a little bit. M is the positive answer to 2i times the square root of 10. Or m is negative 2i times the square root of 10. Some people prefer to move the I and place it at the end to write it more in complex form. So you could also say that m is 2 times the square root of 10i, or negative 2 times the square root of 10i. And be careful, the i's are outside of the square root when you write them that way. So that would be our solutions to this quadratic equation. The two imaginary numbers, 2i times the square root of 10, or negative 2i times the square root of 10.